I wanted to explain a little bit about this first lab. We will be having a lab on campus, however, you can tune in virtually, right? So it's a little awkward because there will be people here that I'm talking to, and there will also be people virtually who are also participating in the lab. I have not decided exactly which lab we're doing yet. As soon as I have, there will be a link to it here, and I'll also email you what that lab is so that you can look at it in advance. Some labs you could also physically do the lab at home. And then otherwise, if you can, you should come to MIWA, right? Especially because after the lab, you could ask me questions about stuff that you don't know. Like, for example, I just went over a bunch of chemistry questions that people were having a hard time with, and we just did them together right after they did the lab. So keep that in mind, right? If you come to do the lab, you could also do DBAs with me during that time. You could ask me questions. The best thing to do is to come with a specific assignment or concept that you're struggling with. That way I will know exactly how to help you, right? So if you say, hey, I got question 5 wrong, can you please tell me how to do it? Or I think it's this, can you explain it, etc. Then that way I can really have focused help for you. Okay, so that was my spiel about labs. Now let's talk about what we're gonna do today. So today is just going to be a really quick check-in. So the way that these virtual sessions are going to work is the following. We're gonna go through some practice problems that I came up with based on material presented in the first module, right? And some of it might seem super easy, but we're just gonna make sure we all get it, and then we're gonna move forward. And then there's gonna be an open time at the end for you to ask questions. So I'm gonna give you guys right now 2 minutes. I want you just to go look at your grades in Earth Science, and I want you to see if there's anything that you have a question about, right? A specific assignment, something that's coming up even maybe that you've already looked at and you're confused about. So spend 2 minutes just looking at your grades and kind of reflecting on if you have any questions. And you might not, and that's fine. But I'm gonna be quiet for these 2 minutes. In fact, I'm gonna stop sharing my screen for a second. But keep looking through your grades, thinking about if you have questions about anything. Okay, so hopefully you were able to look through and see if you had any questions, right? Literally, you might have actually thought, nope, I don't, which is fine. We will get to the point where you might have questions later on in the class. You might never have questions, that's fine too. So just keep in mind, right, I'm here to help you with your questions if you have them. So what I'm doing right now is I'm actually creating a virtual session assignment for this virtual session. What we're gonna do is we're gonna have a code word that I'm going to type into the chat towards the end of the session so that you have to stay. And all you're gonna do to get full credit for this is submit what the code word was, and people who don't do that are not going to get full credit for being here. These check-in office hours ones are literally about coming and checking in and doing the checks for understanding questions, and that's it. So if you don't know the code word because you are watching this as a recorded session, right, you're not going to be able to earn the points for attending these virtual sessions live. And that's just how it's going to be, because these are required, right? If you have a schedule conflict, do your best to work around it. So I'm going to type that out really quick in this assignment. If you don't know the code word, you have credit for this. Okay, sorry, that was a lot of me typing and staring, but so it's going to be 10 points, which isn't a crazy amount, right? But keep in mind, we do have these virtual sessions every week, right? So if you're not attending them, it is going to start impacting your grade in a negative way. And this is going to be due for you guys today. I just put it in there. So as soon as we're done with the session, you should be able to go in there and type in what the code word was. Pretty exciting stuff. Okay, so we'll go back to sharing screen here. And I made this little PowerPoint for us to go through. All right, so we're going to check our understanding of scientific method, measurement tools, estimating measurements, and SI units. All stuff that's been covered in this first module, right? A lot of this stuff is like intro to science, basic science. You've probably seen it before in other classes. It's not necessarily like purely earth science, right? It's science in general. So our first check for understanding question that we're going to do here is, we're going to talk about experimental design and variables. Oh, good. Vitali, I'm going to write your question down here that you said in case it gets pushed to the top of the chat. And we're going to look at it at the end. Okay, but I'm glad that you mentioned that. Okay, so Mr. Ling is designing an experiment to test whether different liquids, specifically coffee, water, soda, and Gatorade, will affect the height of some radish plants. Okay, that's what he's doing. So we're going to identify our independent variable, dependent variable, control variables, if there's a control group, and then we're going to write a hypothesis, right, which is all basic science experiment kind of stuff. So we'll start with our independent variable. Would anyone like to suggest in the chat what Mr. Ling's independent variable could be here? What is he as a scientist changing? Liquid type, exactly, right? So type of liquid, you could even write out each one, coffee, water, soda, Gatorade, right? But that's what he, as the scientist, is choosing. And that's what's important about that independent variable, is you can only change one thing, right? Only one. So in this case, he's changing the type of liquid. Everything else needs to be the same. Same cups, same plants, same age of the plant, same amount of sunlight, right? Same temperature. All of those things are going to need to be the same. So dependent variable, we already had someone bravely recommend an option here, and you're right, is the plant itself. In this case, what specifically is he measuring about the plant? The height, right? So height of the plant. Because think about it, you could measure a lot of different things in a plant, right? You could measure the color, you could measure how many leaves, you could measure how wide the plant grows, right? There's a whole bunch of different things that you could measure. You could even measure like the health, right? If you had a way to quantify that. But in this case, he's going to measure the height. This is a pretty fun experiment if you like to do experiments at home, especially if you want to make your house smell really bad. Water some plants with Gatorade. They ferment and it smells like vomit. All right. So what about our control variables? I kind of mentioned these already, but let's see if you guys are listening to my rambling. What is he going to have to keep the same in his experiment? Emma was ready. Cup. Exactly. Cup or pot or outside, wherever he's planting it. The sunlight, right? The temperature, the actual plants themselves, right? Some of this stuff probably seems like common sense. You're like, well, duh, of course he's going to need to do that. But it's not always, that common sense when we are designing an experiment, right? Thinking about what soil is a good one. Thinking about what we're keeping the same can sometimes be harder in some cases than picking our variables for independent and dependent variable. All right, so we got to have the same cups, the same amount of sunlight, the same temperature, the same plants, the same soil, right? The same amount of attention even. Did you guys know that if you talk to plants, they will actually grow more, right? Because you're breathing carbon dioxide on them. Guess what? They love carbon dioxide. So you can't talk to one of your plants and ignore the others. You got to talk to all of them or talk to none of them, right? But even just little things like that. Okay, and then what about a control group? So our control group is our normal condition. So what is normal for a plant? What do plants normally get watered with? Big hint in what I said. Water, right? So our plants that are watered with water, that have water, that's our control group because that's normal, right? How are we going to know if all these other liquids help if we don't have a normal plant to look at, right? Because if our normal plant barely grows, then maybe radishes just aren't growing well, right? Maybe you didn't have enough sunlight, maybe you didn't have enough something else, and it wasn't actually the liquids that was impacting it. So in this case, you would want to have a control group. Now, do you guys think that we have a control group every single time that we do an experiment? I see a couple no's. Another no. Yeah, you guys are right. No. Right? We have one probably, I don't know, 50% of the time. Sometimes control groups are a little weird. They don't seem like a control group. For example, I'm growing bacteria with my biology class. Our control is actually one of our Petri dishes that didn't get exposed to anything because I want to make sure that it's not compromised before we even put bacteria on it. Right? So control group can be tricky, but there's not always one. All right, now hypothesis. We're just going to practice writing one, and I would like to see all 11 of us that are here today popping a hypothesis into that chat. This is a beautiful format that you can use, that you don't have to use, but I suggest it. The if statement is really where you write what you're doing. So you might say, if we water plants with different liquids, the next part of the hypothesis is going to be what you think, which is the part I would like for you guys to do, and your reasoning. So if we water plants with different liquids, we'll all assume we have the same if. You're going to say, then I think whatever you think, because whatever you think the reasoning is. And I want to see every single person contributing a hypothesis here, because remember, hypotheses cannot be wrong. They can just be disproven, but they're not wrong. So take a look at those 4 liquids and come up with a hypothesis. So when you've got one written, paste it into the chat so that we can kind of see what everyone is thinking. Okay, let's see. I'm just going to read a few of these. Ooh, so many. All right. Amanda says, I think the plant that's watered with water will have the highest height because water is used to water every other plant. We water plants with different liquids and the plants will grow slower because no one waters plants with soda. Okay, so Vitali, you want to specifically state that if we water with soda, then it will grow slower. If plants are watered with different liquids and the plant with water will grow the best. We water plants with water, will grow faster and healthier if it's watered with water, not coffee soda or Gatorade. Okay, so seems like most of us are in agreement that water is going to be the best and these other liquids are not going to benefit plants. So my only feedback here would be to you guys, make sure you're being specific in the hypothesis, right? Don't worry about it being too long or wordy. You want to be specific. So you could break it down by liquid. You could say if we water it with coffee, that plant will be the shortest because coffee has caffeine and that can't be good for plants, right? And Gatorade would be the next shortest because Miss Jamie just said that it smells like vomit and ferments. And then maybe that soda would be the next shortest, something like that, right? You could rank them by liquid, or you can just pick one that will be the tallest or one that will be the shortest, right? But you want to be specific about which one you're picking. Because then when you look at your data and you look at your results, you really need to be thinking, okay, well, I said soda would be the shortest. Is soda the shortest? Yes, it is. Okay, my hypothesis is supported. If you say some of them will be shorter, well, I mean, which ones, right? You need to be specific here about exactly which liquid you are talking about, okay? So think about that when you're writing hypothesis, being specific. Everyone wrote some really great stuff, and I would agree with you guys. I've actually done this experiment, although not with coffee, but soda and Gatorade are not good for plants generally. So that was our first check for understanding. That was our longest one. Don't worry, we're almost done. Okay. So our next question is a multiple choice question. So don't put anything in the chat yet. We're going to read the question, read the answers, and give everyone a second to think about it. Which tool would we use to measure the volume of a liquid? We have choice A, a beaker. Choice B, a triple beam balance. Choice C, a graduated cylinder. And choice D, an Erlenmeyer flask. So, what you know, you could type A, B, C, D. You could type the word. Oh, yes. Oh, yay, looking good. Everyone is saying C. You are correct. Graduated cylinder. Now, beaker is not completely wrong if you were thinking, beaker maybe I could use, right? If you're measuring the volume of a liquid, a lot of liquid, for example, 2,000 milliliters, right? That's a huge amount of liquid. You could use a beaker for that because there are beakers that are really, really big to measure liquids that large. Usually we're using smaller amounts of liquid, so we would, in fact, use a graduated cylinder. Now, let me ask you guys this. What's an Erlenmeyer flask? Does anyone know what that is? Did I make it up? That's what it looks like, right? Erlenmeyer flasks are these weird triangular shaped beaker type things. They're used in a lot of different chemistry experiments, right? Especially when you're boiling liquids, because you can easily attach tubing to the top of these so that you can separate things by the boiling point, right? Because if we have, for example, water and alcohol mixed together and we want to separate those things, they're both liquids, they both look clear. How do we separate them? Well, we can actually boil the alcohol off, have it go up a tube and go to another area where it cools down and condenses. So Erlenmeyer flasks would be used in situations like that. They're not usually for volume. Okay, and then triple beam balance, hopefully we're all familiar with that, right? That is a way to measure mass. Okay, so, oops, next question. We're gonna estimate the length of these objects, and then we're going to talk about precision a little bit. So let's start with the blue crayon, which I know I say that weird, I can't say it right. How many inches would you say it is? Okay. Ooh, I see 333, 2.9. Amanda going out there on the limb. I'm gonna have to kind of maybe go with Amanda here. If we're looking at exactly where the end of that crayon is and coming down, it looks like it's just shy of 3, right? To the point that you could say 2.8, 2.9. You could also say 3. That's not wrong either. Now, if we want to be precise, right, first of all, we probably would never use inches, but this was the best picture I could find. We want to think about how precise we can be on this type of ruler. Really, what are these lines here? We have 3 of them, right? We assume this one is 0.5. So what is this one, 2.5 and 7.5? That seems kind of weird, right? The markings on this ruler are kind of bad. But regardless, right, if you have smaller markings, you could estimate better. But because we don't have smaller markings here, it makes it really hard for us to estimate. So you could say anything, I think, from 2.8 to 3, and you would be correct. Now, what about the, oh my gosh, someone keeps calling me. I'm in a virtual session. Okay, so centimeters is our next ruler type here, and we see a pencil. So what do you guys think we would estimate for the pencil? And I really like people who are putting units in the chat. Very important, right? You could abbreviate those units as cm if you would like, but units are super important because 16 centimeters is going to be very different than inches, right? So most people are saying 16. I would agree. It looks like the pencil comes almost there. You could also say 15.85. I like it. 15.9, somewhere in that range, right? Again, this ruler does not have really tiny markings. You guys have probably all seen rulers where they have the 10 lines in between 3 and 4, right? When we're measuring something, that's probably the type of ruler that we want to use, so that we can get as precise as possible. Because really what you want to do is you only want to guess to 1 unit. So here, since we don't have any markings between 15 and 16, that would mean we only want to guess 0.8 or 0.9. If we did have those markings, then we could guess 15.85, 15.87, right? Because then we're actually guessing in between the 2 lines. So you really only want to guess 1 decimal place further than what is offered, if that makes sense. Regardless, not the most, biggest deal in the world. If you used 15.9 instead of 16 and you did your calculations, you're going to be very close. Okay. And then the last little check for understanding here before we open it up to questions, which we have one. What if it's in multiple choice? Yeah, so that's annoying, right? Because then you have to pick the closest answer that you possibly can. That's a really good question, Tali, and it's really hard to say. Like, for example, on this question, if they had said 15.9 and 16 as answer choices, which they would hopefully never do, right? It would be really hard to decipher which one to pick. So do your best on the estimating ones. If you think you've estimated it and the correct answer is a different answer than what you think it should be, then please email me and I'm happy to hear your argument for your number, right? And then we can discuss it. So what does it mean to be an SI unit of measure? Good guess here, centimeters and inches. Well, I'll tell you this, centimeters are, well, meters are an SI unit, but inches are not. Anyone want to give us a guess? You could Google this, by the way. Google SI unit and try to put it in your own words and tell me what it is. Kilogram is one. Metric units, great job by River recognizing both meters and kilograms are metric units. We'll put a question mark there. For time, it's seconds, good. It should probably be kilometers for here, right? Or is it meters? Still waiting for someone to suggest a definition for SI unit, what that means. Kelvin. Kelvins are the weirdest temperature, right? Because no one uses them except in science. Thank you, Emma. International System of Units. Right, and really what that means is that scientists literally sat around and said, okay, what are we gonna make the standard unit for distance? What are we gonna make the standard unit for time? What are we gonna make the standard unit for temperature? And they decided and made a list, right? Are they super important to have memorized? No. But it is important to note River's point here, which is that they are metric units, all of them. Nobody uses inches, feet, yards, Fahrenheit, any of that stuff, right? Sometimes you will see, actually most of the time you'll see Celsius used for temperature rather than kelvins. You'll see seconds for the most part, although sometimes people will measure in minutes, right, or hours, depending on what they're measuring. So you want to use this as a reference if you're measuring, but really what you want to think about is what is going to make the most sense for what you're measuring. If I want to measure how far it is to travel from Portland to Florida, am I going to use meters? Probably not, right? I'm going to use kilometers because I want to get the biggest unit I possibly can. If I'm going to measure how long you're sleeping, am I going to use seconds? No, right? That's a lot of seconds, unless you sleep for like 10 minutes, right? That might be reasonable. But if you're sleeping for hours, right, I would measure the time that you slept in hours. I could always convert it to seconds if I wanted to, right? So really, the SI units are a really good reference point for what the standard is. However, you really want to think about when you're designing your own experiments or you're doing any kind of experimental measuring, you want to be thinking about specifically, basically, what unit makes sense for what I'm doing, right? And I'm sorry, but we won't use inches or feet or miles, even though those are things that we use every day. Okay, so the next question is a slide about questions, where we're going to go over what the code word is. And then if you don't have any questions, you can leave. And if you do have questions, then you stick around. And even if you don't have questions, but maybe you want to see what other people's questions are, right? You could do that. I'm just screenshotting who's here also as a backup. Okay, so the code word is going to be in the chat. If you are tuning in after this session has occurred, you're not going to know the code word. And please don't share the code word with your fellow earth science students, because that is, no, it doesn't have to be in all caps, because that is how you're going to get credit for being in the session. And I know that is important to you guys because you took time out of your day to come to the session. So it does not have to be in all caps. I just put it in all caps. So what you're going to do is when you leave the session, you're going to go to Canvas. You're going to see on your calendar, there's a brand new assignment that I just created that's due today that is called Virtual Session 2 Check-in. Literally, the only thing it says is, what was the code word? Then it says, if you don't know the code word, you can only receive half credit for this assignment. Please explain why you were unable to attend and if it is possible to change your schedule. Right? The reason I'm doing that is because I don't want to penalize people who, for example, are in school during this session. They can still get half the credit. So all you're going to do is submit the code word there to let me know that you were here. Right? You could also use that space to ask additional questions, especially if it's like you think something maybe that only relates to you. All right, so once you have the code word, if you feel confident, you don't have any questions, you don't care about anyone else's questions, which is fine, right? Then goodbye. Otherwise, we are going to start taking questions. And, oh, I already see people turning it in. I have the Canvas app and it tells me as soon as you guys turn stuff in. River, Jack, Amanda, Vital. Wow. 5 people already turned it in. Amazing. Okay, so we did have a question about theories and laws. Bye. From Vitali. So the thing is, I don't know if my question 4 is going to be the same as yours, so we'll see if it is. Actually, here's what I'll do. I'll stop sharing. I'll go specifically into your quiz and get it. Otherwise, guys, if you do have a question, please pop it into the chat so that we can work on getting that one. We're going to be looking at theories and laws, question 4, which we will find out exactly what question that is in a second. Okay. Okay. Sorry, give me 1 second, guys. I'm trying to find this quiz here. Okay. Okay. So, theories and laws. Question 4. Okay. So, I'm going to protect your grade here, but I will show specifically your quiz, Vitali, but I moved it over so that you can't see your grade or your name. Okay. Okay, so question 4 says, a scientist wishes to represent the location of an earthquake in California. Which type of model is most appropriate for this purpose? Okay, so can you explain why you said computer simulation? Because I think that's a good guess. Okay, because that's what they used to tell weather. Okay, but it was maps. Okay. Yeah, so I think your thinking is pretty solid here in terms of you're thinking basically like a computer simulation of a map, right? Because that's what they use for weather, is it's a map that shows movement or what's going on. So in this case, I think that map is the best answer because they're talking about literally representing geographically where the earthquake is, and not necessarily showing the earthquake happening or how it moves or impacts. I think I could give you some points for that, though. I'll give you 1 point back for that, because I think that your argument is valid here, that computer simulation could also imply map, right? Okay. Do we have any other specific questions about the quizzes or assignments or anything coming up? Okay, I just updated that for you, Vitali, so you should see 1 more point added back to your grade for that one. But I think that's why they're wishing to see maps there, is because they really want that geographic pinpointed location. Okay. All right. And Kaylee, do you have any questions? You can unmute yourself if you want. You could talk. You don't have to type if you would like. You're the only person left in my virtual session, so.
Anyone else?